Today we'll be looking at base functions. To begin looking at base functions, if we just recall that what we learned in grade 10. So in grade 10, what you guys used is y equals x squared as a base function. You use this base function so that you were able to graph other quadratic functions. And those other quadratic functions, you use transformations to be able to graph them. So in grade 11, what you do is you need to know the other functions base and be able to use transformations to graph them. So we're going to look at a couple different functions, and we're going to begin looking at our quadratic function, which is a function that you are very familiar with working with from grade 10. So what we're going to want to do from after this lesson is I want you guys to be able to draw your base functions without using a table of values. Now when we go through this, we are going to use our table of values. Recall, this here is our table of values. So in this lesson we will be using it, however, I want you to get familiar with enabling yourself to be able to draw your base functions without having to actually do your table of values each time. So let's begin here. So we have our quadratic function y equals x squared. Our y equals x squared is our base function. So now we're going to complete our table of values. So remember, when we're doing our table of values, you're just going to sub in for your x value and you're going to figure out what y will be equal to. So if I sub in -3 here, I would have y equals -3 squared. -3 squared is equal to 9. So I put 9. Similarly, when we have x equal to -2, we'd have y equal to 4. And we can continue doing that throughout. So we would have when -1, y would be 1, 0, 0, 1, 1, 2, 4, and 3, 9. So property of a quadratic that on either side of your vertex, the quadratic will be the same. So now we can go ahead and graph this. So when we graph this, remember that you need to graph your x-axis first and then your y-axis. Okay, so your x-coordinate and y-coordinate. So we first graph -3, 9. So from the origin, you're going to move 3 left. So 1, 2, 3, and up 9. So we get our point here. Alright, our next point is at -2, 4. So again, start at your origin, move 2 left, up 4. Our next point, -1, 1. Start at the origin, left 1, up 1. And then we have 0, 0. And then 1, 1, 2, 4, and 3, 9. After we have plotted those points, we can connect them with a curved line that should touch my origin there, and always label. So this will be our y equals x squared. The next function that we want to look at is our linear function. So again, we have y equals x, which is our base function. linear functions should be something that we're very familiar with, but we will still review. So when x is -3, y would be -3. When x is -2, y would be -2. -1, -1, 0, 0, 1, 1, 2, 2, 3, 3. That's just found, subbing in, and we see that y is equal to x. So whatever the value of x is in a linear function, y is going to be the exact same thing. So now we can go ahead and graph those points. So our first point is -3, 3. So remember, left 3, down 3. Next one, -2, 2. So left 2, down 2. Then left 1, down 1. 0, 0, 1, 1, 2, 2, and 3, 3. Again, once you have those points, then you can just go ahead and connect them. And what we get there is a straight line, meaning it's linear. Always make sure you label. Not only do you need to make sure you always label your graph, make sure that you also label your axes, your x and y axes. We will now look at our root function. So our root function is f at x equals the square root of x. So that is, again, our base function anytime we're working with a root function. Also, I want you to note this is in function notation. Recall that f at x is just the same as saying y equals the root of x. It's just different types of notation. One is in function notation, the other one is xy notation. So now we can go ahead and complete our table of values. Again, remember, this isn't something that I want us to get used to doing all the time. I would like us to be able to graph a base function just when you see it. So if you notice here that all of our x values are from our 0, 1, 4, 9, and 16. The reason for choosing these x values is because we can never have a negative root, because if we have a negative root, then it means we would have an imaginary number, which that can't happen. So therefore we need to know that we won't have any negative x's, so we start at 0. And the reason for choosing these values is because these are perfect squares, so they're easier to graph. So when x is 0, we sub in underneath the root sign, and the square root of 0 is just 0. Okay, so then if we sub in 1, square root of 1 is just 1. Again, sub in 4, square root of 4 is 2. And we can continue. When we sub in 9, it's 3. And when we sub in 16, it's 4. So now we can go ahead and graph this. So when we graph these points, we have 0, 0, 1, 1, 4, 2, so over 4, up 2, and then 9, 3, and our graph's not large enough to graph the 16, 4, so now we can just connect those, and again that is a curved line, and label y equals the root of x, or you can label it in our function notation, so f at x equals the root of x. So now let's look at a rational function. So a rational base function is just f at x equals 1 over x. So we are going to look at two different table of values. The reason being is one is all positive and the other one is all negative. The reason for doing this is if you think about anything, 1 divided by 0 would be non-existent. as it does not exist. You can never ever divide by 0. So we just split them up so that we can look at some smaller values. So let's first look at when x is equal to a quarter. So when x is equal to a quarter, we have f at a quarter equals 1 divided by 1/4. We can rewrite this as 1 times 4 over 1, which would just be equal to 4. Similarly with a half, this would be equal to 2. Now when we divide 1 divided by 1, we just get 1. When we divide 1 divided by 2, we get a half. 1 divided by 3, we get a third. And then a quarter when we divide by 4 for our x. Now, the same thing's going to happen when our values are negative. The only difference is, instead of being positive, they're going to be negative values. So we have -4, -2, -1, -1/2, -1/3, and -1/4. So now what we're going to do, we're going to go ahead and actually graph these values. So these values, a lot of them are going to be really small. So when we are graphing these, sometimes what we'll do is we'll just take a couple of the points. So if we're looking at a quarter, we have our value to be 4. So you move over a quarter and up 4. So we'd have a value somewhere around there. Now be sure not to touch our y-axis. Sometimes we might brush on it, especially when I'm doing this program. However, you will never cross your x or y axis. When we have a half, we have 2, so over a half up 2. 1, 1, 2 a half, 3 1/3, so the values are getting smaller, and then 4 1/4. So you notice the values are going to get really, really close to our x-axis. So now we can connect those on that side. So they're going to get close, but they're never going to actually touch. And then we can do on the negative. So when it's a -1/4, we have 4. A half, we have 2. -1, -1. -2, -1/2. And -1/3, and -1/4. So again, notice that our values get really, really small, but they're not going to actually ever touch our x or y axes. Label our graph, f at x equals 1 over x. Now we have a question here that we need to complete. Why does the graph appear only in the first and third quadrants? Well, the reason for that is if you divide it by 0, the function does not exist. And what we call this is called an asymptote, because what that says is that the the graph will never actually cross the asymptote. So it will never cross the x or y axes. Now, just to give you a definition of an asymptote is a line that a curve approaches more and more closely but never touches. So I have an example below here. So in this example, for instance, we have x is equal to 2. Now, when x is equal to 2, what we call this is actually a vertical asymptote. And also, if we look at our one below here, say at y equals -2, It wouldn't be called a vertical, it would actually be called your horizontal asymptote. So you can write that down as well. So this is just an example when you have an asymptote that isn't 0 for your vertical and your horizontal, like it was in our previous example when looking at our base function of our rational function. So asymptotes can exist at other places other than 0. Now we will look at a cubic function. So our cubic function, y equals x cubed, this is called our base function. Again, I am hoping you guys all learn your base functions and are able to graph them without having to do your table of values. So your table of values here, we start at -2 and go up to +2. Again, just sub in for our x value. So if we sub in -2 and cube that, we're going to get -8, because remember -2 cubed is -2 times -2 times -2. So this gives us -8. When it's -1, again sub in, so -1 times -1 times -1, so that would be -1. 0 would be 0, 1, 1, 2, 8. Now we can go and graph this. So when we graph these values, over 2, down 8. It's a little bit off our graph. -1, 1. 0, 0. Now 1, 1. And then 2, 8. So with a cubic function, again, it is a curved line. So we go up and we do a little S kind of pattern with our cubic function here. And this is y equals x cubed. So now we will look at our exponential function. So with our exponential function, it's when we have our x as our exponent, hence exponential. So we have y equals 2 to the power of x, which is our base function. So now we can go ahead and fill in our table of values. So when x is equal to -2, we have y equals 2 to the power of -2. So bringing us back to our exponent laws and rules, we're going to flip this. So it becomes 1 over 2 to the power of 2. And now we can evaluate this. So it's 1 over 2 squared is 4. So it's a quarter. Similarly, when our x is equal to -1, 2 to the power of -1, we flip it. So 1 over 2 to the power of 1, which is just equal to a half. Next, if we have 0, so if we put 0 into our exponent, 2 to the power of 0, anything to the power of 0 is always going to be 1. Again, put 1 in, we get 2, 2 in, we get 4. Now we can go ahead and graph this. So when we graph this, we're going to start at -2. So -2, it will be a quarter. At -1, it will be a half. At 0, +1. At 1, it will be 2. And at 2, it will be 4. So you notice here that it slowly increases, and that after we hit our x-axis, it increases extreme amount compared to on the left-hand side of our y-axis. And we can label this as y equals 2 to the power of x. So there's your base functions that you need to make sure that you are aware of and know how to graph without using a table of values.